The latest version of Multiphonics CV-2.1 features some new modules and some new factory presets which you can find in the wave shaping category. I will now recreate for you one of the patches I did, the Rectified Winds patch, which is a classic triangle wave-based synth lead. We'll start with a basic one oscillator lead architecture. A compact VCO set to a sawtooth wave, controlled from the keyboard via a glide module for portamento. Legato portamento, so gate is routed into the reset input. This goes into the polarizing mixer, which purpose will become obvious in a second. Input 1, but this is closed. But once you press a key, the ADSR envelope will open this input and let signal through. This goes classically into a ladder filter and into the output VCA, which in our case will provide us with some velocity sensitivity. This goes into the output, some velocity, and we open the bias and we should hear it once we press a key. Let's adjust the envelope, quick attack, quick release, full sustain, and let's open the filter. Filter will also be controlled from macro 3. And as in the classic architecture, another ADSR to provide us with a filter envelope. So this is a sawtooth based lead, one of the easiest patches to make. Now let's use the new modules. First, a new visualizer panel, microscope, which is a simple oscilloscope. Let's see what's coming out of the mixer. A sawtooth wave, as expected. Now let's turn this sawtooth wave into a triangle wave in a way that is done on analog synthesizers. We'll use a shaper panel, a new module called Rectifier. What it does is that it outputs only the positive or negative halves or inverted variations. So let's add 2 more microscopes and see what's coming out of the positive rectified and negative rectified outputs. We can see that it's the positive half of the voltages of the sawtooth and a negative half. And once these are routed into the mixer, controlled of course by the ADSR, they recombine into a sawtooth, which is no surprise. But look what happens if I invert this with the polarizing function of this mixer. This negative half got inverted and completed a triangle slope. Let's adjust the trigger levels so this is not erratic. There is DC offset, so we'll enable the AC coupling on the rectifier. So this got centered on 0 volts. And now we have a triangle wave with this little glitch at the summing point. Which is actually what happens in analog oscillators, which shows us that Multiphonics takes great care to emulate how a voltage-based modular works, not just a digital representation like mathematically perfect triangle wave, and this little glitch gives us this little high frequency edge that makes it a bit brighter than a regular, like a mathematically correct triangle wave. Okay, so let's move forward from here. We'll use another shaping module, which is the wave folder. We'll add it between the rectifier, between the mixer and the ladder filter. And the ladder filter will accept this signal here. And what a wave folder does, it folds back the top of the wave. We can see that using a fourth and final microscope. We can see this folding of the peak at the positive and negative maximums. And we can make this depend on velocity, but just a tiny bit, so the timbre varies, becomes more aggressive, more distorted with velocity. Okay, we can use some smoothing on this. Close the filter. Apply some effects. So we have our timbre that we heard in the beginning, apart from some modulation. We now need an LFO routed through a VCA that will allow us to control the modulation level with the mod wheel. Route it into the filter. Okay, this works. And now let's use Mod 2, which is Aftertouch, to close the filter if we press down the key. So we can also do this manually via Aftertouch. So we're almost done. Let's use the two remaining macros. We'll route macro 2 into the shape of the compact VCO, so we can turn it into a pulse wave. Actually, the positive output would work better, providing full range. But as you can hear, this gets quieter as we go up, so we'll route this into the output VCA to provide volume compensation. And this will work on the bias. Let me show what bias does. We'll turn off AC coupling. It moves the waves up and down, meaning the rectified portions will be different, and the summing will be different. But depending on the settings of the other macros, this can mean that the volume will go up and down. So to compensate this, we'll invert this macro and route it into the output VCA to provide some compensation.